Okay, good evening, all of you. I hope you are very well. On previous class, I have discussed about the steam power plant, how the steam power plants operated. Okay, and the main components of the steam power plants. What are the main components of the steam power plants? I have discussed about it on previous class. You may know that a class has been completed of the SF and PM bending moment and shear force diagrams. The chapters, these are new chapters. I have discussed about some things about these chapters. You know that's the how many types of the beams are there is also the how many types of the loading conditions. Okay, basically we know the generally I am repeating these topics in very shortly. Okay, the generally beams are the generally so many types of the are the beams. Okay, one is fixed cantilever beams, continuous beams, uh, overhanging beams, and simply supported beams. Also, I have discussed type of loading conditions unit UDLs, UVLs, also point load. Okay, so I will discuss about this in briefly. So let's on. First of all, I have to understand what is SF. SF means shear force. What is shear force? Here the shear force is the definition is given that the SF at any section of a beam is the algebraic sum of the all the forces, including the reaction force, but reaction force acting normal to the uh, axis of the beam either to the left or to the right of this section. SF is nothing but SF is the shear force which is the is equal to the algebraic sum of the all forces which are acting either to the section left or section right. That is called shear force. So when I go for in details for analyzing it, then it will be very clear to you. Okay, next point is bending movements. Let's go on bending movements. Bending movements is the bending movement at a section in a beam is the algebraic sum of the moments of the all forces including support reactions, that is we take the supporting reaction which the support the beams. Okay, support reactions uh, about the section the about the section of the beam either to the left or right to the of this section. That means that bending moment is that of the section of the beams is the algebraic sum of the moments of these forces which are acting on the beam of this section. It will be either left of this section or it will be right of the section. So from here we can understand the bending moment is the equal to the algebraic sum of the moment of the forces which are acting on the beam on the beam on the axis, which will be either right or to the left of this section. Okay, so let's go on in details so it will be very clear to your understand. Just I have to reerase it. So to draw this a diagram, the SF, how to calculate the SF shear force of this of the simply supported beams. That's why it will be understands how the how can you understand the shear force diagram. Okay, let's see, have a look. SF of a simply supported beam. Okay, SF, how to calculate the SF simply supported beams. Let's take a half. This is a beam. This is a supporting. This is a also supporting, and at the midpoints a load is acting W. At the on the right hand, on the left side, a reaction force RA acting at this point. This is A point and this is B point of these beams. Also another a reaction force RB is acting. Uh, this is beams. We assume this we can if we calculate is it this diagram, it will be very clear to you. Let's take a section on this left side. This is section x and x. This is x section. At this midpoint, let x. At this midpoint, let's x. Okay, have a look. Uh, this is a beam A point, and at A point B point the two reaction force acting, which is this direction is called anti-clockwise directions. A reaction force acting under directions about this axis, and also the another reaction force which is acting at a B at a which is clockwise direction. Okay, about this axis, x axis we take this x axis, and is the W is the load which is acting at the midpoint of this string. So let's have a look on the left side of this section. Sorry, on the right side this of this section, x section, let's take is Q, and on the right side, on the left side of this section, take a P portion. That's the Q portion and the P portions. Okay, two portions are combined a beam. So on Q portions, let assume on Q portion a reaction force RB is acting at B point. Okay. also take a this is S, the upward force, sorry, downward force as acting on the Q portion by the P portions. This is S1 and also this is S2, which are acting upward directions on the P portion by the Q portion. Okay, be concentrate. I'm repeating against. This is the beams. A load is acting at the midpoint of these beams, and the two reaction forces acting at A and B point. Okay, RA and RB. Also, later takes a section, assume that X sections. This is X sections. On this right side X section, take a portion. We give this name is Q portion. On the left side, the section we give the names is P portions. Also assume that S1 and S2, these are two shear force of these two portions. S1 is the Q portions, S1 is the shear force of the Q portion, and S2 is the shear force of this P portions. Let have when the S1 is acting on the Q portion by the P portions, so the equilibrium will be the force equilibrium. So shear force equilibrium will be when sorry, I have write down this already. When or the q portion is when on the q portions a reaction force is acting at B point, and also S1, this is called shear force. Shear force, sorry, S1 is a shear force which is acting on the Q portion by the P portion. Okay, P portion দ্বারা Q portion যে acting হচ্ছে, this P portions, S1 is the shear force. So by the equilibrium conditions, by equilibrium condition, by the equilibrium conditions, we know that by the equilibrium condition we know that S1 equal RB reaction. Okay, because there is no force instead of S1 and RB, the both are force are acting on this portion Q1. If the R1 is acting in as anti-clockwise directions, so S1 is acting so the clockwise directions, this anti-clockwise, it will be create a momentums. Okay, so S1 equal RB. On the another sense, on the Q portion, on the P portion, RA is a reaction force which is acting at a point, which is acting a points, and also S2 is acting on P portion, on P portion. Okay, by the by the Q portion for equilibrium condition, for equilibrium condition, for equilibrium জন্য তাহলে S2 equal S2 equal for equilibrium conditions, S2 equal the on the left hand side, right on the left hand side, the force instead of S2, the remaining are the two forces acting on these beams. Okay, let's take it. RA is take is positives and W is take is negative force. Okay, sorry, it's not right properly. RA minus RB. Why I have taken minus W? Because the we take is W force is acting in clockwise direction. We take it, so it's a negative signs. The forces which is acting anti-clockwise directions, this is take as positive signs. So by this formula, if we equality, so RA minus W equal RB. If we equates it, this will be same, so it will be RA minus RB W. Sorry, it will be minus positive RA plus RBW. So here we can write its RA means S1 by S2. Okay, this is S1 is when the S1 S2 is equal, so we can say that the shear force is the algebraic sum of the force which are acting on the left side or the right side but of this section, xx sections is equal. Okay, so from this point we can say S1 equal S2. Also S1 S2 equal, but it may be equal but in the opposite direction sense. Okay, so S1 and S2 in magnitude it is equal, but in direction it is opposite to each other. So from here we can understand the shear force at these sections of these sections is equal. Let's move on. Okay. So moves on the next points. Next point is the bending movements. A diagram has been I have drawn on these boards. This is the beams at the point A. The reaction force is acting at this RA, and at B points. This is B and this is A and this is C. B points, the reaction force is acting at B points. It is anti-clockwise directions. And at C points, a W load is acting at the midpoint of this whole sections. Let's take a sections, x-axis sections, and also a two portion we can see P and Q's. Also takes the distance from RA to X. This is takes us L2, and also from this section X axis to RB, this is takes L1, and also from this C points to the X axis, this will take a distance X distance. By the way, if it's at sorry at the at the when anti-clockwise movement, the anti-clockwise movements, this is anti-clockwise movement, the anti-clock clockwise, the anti-clockwise movement, the anti-clockwise movements, the anti-clockwise movements due to RA, anti-clockwise movements due to RB about x-axis. The anti-clockwise movements, let's take a M1 equal RB, the distance into force. We know the movement is distance into perpendicular force. Here anti-clockwise distance L1 RB. Okay, RB is anti-clockwise M1 is which is acting on the Q portion. Okay, Q portion by the P portion, by the P portions by the by the p portions, so this is equation is this by the p portions. In next step, on another side, the another side on another side of x axis, the movement m is bending movement. This is bending movements. The movements is the algebraic sum of these movements. Which are the algebraic sum of movements? So algebraic sum of movements is another sections R A, sorry, it will be taken R A L L L L2 minus W X. On the left side, the due to the application of the force, we know that two forces acting from the x with the about this axis, R1 and W force are acting on the left side of these sections. They are the movements, the algebraic sum of the movements will be the bending movements by M2 of these sections of this section is the p sections. First of all, we find out the q sections. The movements of these sections is bending movements of the sections. Only there is only one force is acting, Rb. So L1 into Rb is M1. So on another hand, on the q portions, the total movement due to the force and apply on these sections, the force is R1, Ra and W. So the force is Ra force movement is the Ra into L2 minus W into X. Okay, so if the two portion Q and P in equilibrium conditions, that means M1 equal M2. That's why we can write it, if the beam is in equilibrium condition, so we can write তাহলে m1 equal to m2 যদি ইকুইলিব্রিয়াম কন্ডিশন, তো বেন্ডিং মুভমেন্ট কি হচ্ছে, অন দ্য লেফট সাইডের যে মুভমেন্ট অফ দ্য ফোর্স আর সেকশনের রাইট সাইডের মুভমেন্ট অফ দ্য ফোর্স যদি ইকুয়ালিটি হয়, তার ফলে কি হবে, বিমটা ইন ইকুইলিব্রিয়াম কন্ডিশন থাকবে, সো দ্যাট m1 ইকুয়াল m2. তো আমরা এটাকে আমরা লিখতে পারি L2 into RB by equal RA L I think L1 হবে, it will be L1, L2 not, it is L1, it is L2 minus WX. This is the equations, bending equations. So here যে মুভমেন্টের জন্য তোমার যে বিমটা বেন্ডিং হচ্ছে, দ্যাটস ওয়াই উই কল বেন্ডিং মুভমেন্ট. ওকে, সো if the beam is equilibrium conditions, then it is the equations follow. Okay, thank you. তো আমরা এখান থেকে বুঝতে পারলাম what is bending movements, what is shear force. Clear?